we were doing the exercise of chapter 6 and our sixth question is make a label diagram of a candle flame. Here in our videos we have studied how to make a flame label figure. This is the candle and this is the flame, and in this one this is the hottest portion, isn't it? The top of the flame is the hottest portion and it is the outer zone of complete combustion. It completed the combustion and it is the hottest most portion. Then it is the moderately hot portion. Then middle zone of the partial combustion, that is yellow. If the combustion is partly done, then that will be seen in yellow color, and this is the moderately hot portion, and the least hot portion, that is the intermediate zone of unburned wax. That is the portion where we burn, that is the unburned wax portion, and it seems to be in black color and it is the wax candle. Now it's clear for you how to draw the diagram of a candle flame. It has mainly three parts: outer zone, middle zone and intermediate zone. Outer zone is the hottest one and the middle is the moderately hot zone, and the innermost zone, that is the least hot zone. This is the diagram of a flame. Then the next one, that is name the unit in which the calorific value of a fuel expressed. What? We have seen that, and many times we have seen that we have expressed the calorific value in the unit, that is kilojoule per kilogram, isn't it? Calorific value is defined as the energy contained in the fuel. It is expressed in the form kilojoule per kilogram. Kilojoule per kilogram. Kilojoule, kj is kilojoules and kg is kilogram. Then explain how CO2 is able to control fire. How can this CO2 can control the fire? CO2 is a non-combustible gas and extinguishes fire in two ways. Actually, CO2 is not combusting fire. We said that oxygen, it is helping for burning the fire, but CO2 is actually an extinguisher, that is it will not burn actually. Then it burns it. It helps to extinguish fire in two ways. First one, it is heavier than oxygen and it covers the fire like a blanket and cuts off the contact between oxygen and fuel. This carbon dioxide is heavier than oxygen, so it will cover up the object with the carbon dioxide and it will resist the oxygen to get into that object and that is it prevents the supply of oxygen to the object to get fire. In cylinder, CO2 is kept in the liquid form. CO2 is kept in the liquid form. When released, it expands enormously. This brings down the temperature of the fuel, which helps in controlling the fire. Actually, this carbon dioxide, when we are seeing it in a small cylinder-like thing, actually it is having much and much of carbon dioxide. Then that is compressed and it is in the form of foam itself, isn't it? Then when it comes out, it will expand and this needs some temperature. So the temperature from the fuel will be absorbed. So the temperature needed for that fuel to burn, that is the ignition temperature. The ignition temperature will become less and thus chances to get fire will also be less. This is the way how this carbon dioxide is putting off the fire. Hope you understood. It is very simple. First one, it is denser than oxygen, so it will cover upon the object and will resist the oxygen oxygen to get into that object, so it will burn. Then the next one, it is compressed, and when it is free, it is released, then it will expand very much and it requires some temperature. Its temperature is get up from the fuel. Then the temperature of fuel is lessened, that is the ignition temperature will be lessened, and so the condition for fire will be cut it off. First condition it is to get the oxygen, it will process the oxygen to get into that object, and the second one, the ignition temperature also will be less. This is the two way that CO2 is resisting the fire. Ninth one, it is difficult to burn a heap of green leaves, but dry leaves catch fire easily. Explain why. By common sense that we know that the dry leaves condense less water content, isn't it? And water is less ignition and it is having more temperature to burn that water content portion. So if it is a dry thing, then it will get fire very easily. Then our explanation of answer is a heap of green leaves contain a lot of moisture in it. Hence, in ignition temperature is high. Hence, if ignition temperature will also be high. Therefore, it does not catch fire easily. But dry leaves have no moisture content in it. Hence, its ignition temperature is low. Therefore, it catches fire easily. Then 10th one, which zone of a flame does a goldsmith use for melting gold and silver, and why? Then this is the question related to the intensity of heat for the flame, isn't it? Then we have studied the structure of flame at the above question, and at that time we have said that the topmost portion, the outermost portion is the hottest portion, then the middlemost portion is the medium, moderately hot portion, and the inner portion is the lowest hot portion. Then which zone will be needed by the goldsmith? We can check in the question. We will explain while reading the question itself. The goldsmith mainly uses non-luminous flame, which it termed to be the outermost part of the flame. This part of the flame is used because the outermost flame undergoes complete combustion and it is considered as the hottest part of the flame. Then the goldsmith needs the hotmost fire because it wants that gold, silver to be melted. So they are using the hottest part of the flame. Where it is the hottest? It is the outermost zone, that is the completely burnt portion. So they are using the outermost flame. Okay. Then the next question, in an experiment 4.5 kg of a fuel was completely burned. The heat produced was measured to be 1,80,000 kilojoule. Calculate the calorific value of the fuel. We want to calculate the calorific value. Actually, we have doing first problematic question in our this year, isn't it? Then how much heat is produced it is given that 1,80,000 kilojoules. Then therefore heat produced by 4.5 kilogram will produce 1,80,000 kilojoule. Then how much amount will be produced by 1 kilogram of fuel? It will be done by dividing the entire energy produced with the amount. Then we get for 1, isn't it? Then 1,80,000 will be divided by 4.5 into 1, that is equal to 40,000 kilojoule per kilogram. That is, hence the calorific value of the fuel is 40,000 kilojoule per kilogram. That means whatever is the energy got from burning 1 kilo of a fuel, that is the calorific value of the fuel. itself. Then the next one, 12. Can the process of rusting be called? Discuss. Can process of rusting be called combustion? Discuss. Can we call it as combustion, rusting process? No, because rusting is an exothermic process as heat is liberated during rusting. On the other hand, combustion is a chemical process in which substance reacts with oxygen to release energy in the form of heat or light. And this rusting is also an exothermic reaction that produces heat as it liberates during rusting. Heat is liberated by rusting. On the other hand also, combustion is a chemical process in which substance reacts with oxygen to release energy into form the heat or light. Heat or light is produced while burning. Abhida and Ramesh were doing an experiment in which water was to be heated in a beaker. Abhida kept the beaker near the wick in the yellow part of the candle flame. Ramesh kept the beaker in the outermost part of the flame. Whose water will get heated in a shorter time? This question is asked to how firstly the beaker water will be boiled. Then we know that if you are using hottest fuel fire, then the thing will be burned fastly. Then Ramesh's water will be boiled at first because he is using in the outermost portion, and Abhida will be boiled at the second only because she is using the yellow part. Now it is the completion of chapter 6. We have completed chapter 6. Now we are going to the next chapter. Till then, write this question answer in your book. It is very interesting part. You write the question answer in your notebook. Study well, read it